Thank you. I knew we were going to have some fun up here, fellow Australian. Thank you, Shanice. I just want to thank the organising committee and especially Daniel Tolhurst and Gregor and the rest of the committee for actually inviting me here. I honestly have not been to a EUCARPIA. How does that sound? And I didn't realise there was so much plant breeding application people here that are just ready to dive in to statistics and machine learning and all the other great analytics. Can see so many quantitative people's minds here working away, but we also have some foundational people here, Robin, Rosemary. It's fantastic to see you guys. I haven't seen you guys for ages as well. This is going to be a bit of an overarching talk. As Shanice said, this is not necessarily my specialty, but I'm looking after a multidisciplinary team. I come from a biometrics background. So I've been starting to bring not just like machine learning, artificial intelligence, but mathematics and data science into Australian grains agriculture. And this is a little component of talking about AI and ML and how to align that better in Australian grains. I just want to tell you a little bit about myself first. This is might be a bit of a shock to people, and I gave Daniel the opportunity here maybe to turn off the projector before we kick into some of the slides that are coming up about myself. But we're just going to do it anyway. Most of the time you learn this stuff through osmosis by talking at conference dinners and stuff like that. This is a bit of a forced osmosis onto everyone right now. There's also going to be a bit of an introduction about the Aggie project itself, which Shanice just introduced. And we'll just talk about some AI and ML capability that was around pre-Aggie, and also the alignment of ML AI that's happening in Aggie right now from when the project kicked off to around about now. And you'll see a few proposals, not detailed proposals, but a few proposals that are being thrown up by all the capability and expertise across the strategic partners that are involved with Aggie. And then maybe if we get down to it, if Shanice is not flashing cards at me, that we can talk about a quick summary of just ML and AI in grains agriculture and just in general. So here we go. I'm a part-time traveller. I do like travelling. If you really want to be consistently poor over the lifetime and don't build material wealth, then travel the world from Australia. And I'm sure Gregor and Daniel know that for a fact because they just paid for my flights to get here. Thanks, guys. So I appreciate this one is on the house. This is great. You can see Amalfi Coast there in Santorini, and that picture on the right-hand side there, that's actually a Portugal. If anyone's been down to the bottom of Portugal, that was a 36-degree day. You can see there's no one in the water. Why would that be? Why would that be? It's because the North Sea backs up to Portugal on that bottom end. I didn't realise that. So I just ran full belt into the water and almost degendered myself when doing so. Not realising it was about 7 degrees on a 36-degree day. I'm also a part-time runner. This is not some sort of humble brag. This is actually there's a big story behind this as well. If you look on the right-hand side there, have a look at the Strava there. That is not mine. This is a guy called David Turnbull, who's an elite runner inside Australia. He was good friends with my brother, and he took on this challenge. He wanted me to crew for him. That's 242 kilometres from the coast of Eden on New South Wales to the top of Kosciuszko, which is the highest mountaintop in Australia. 6,000 metres of elevation, that's 2/3 of Mount Everest, on a 30-hour, no sleep, journey. I was there with him the whole time, fueling him every 5 kilometres. This guy told me, not after this race, but before, that he has fallen asleep running twice. Hard to believe. That's me on the left-hand side trying to pretend that I can do what he's doing. I finished a 50-kilometre race just last year. That was the resulting effort down the bottom there. Lots of cramps, lots of everything else. But I still just hack away in my ultra running kind of persona. I'm a part-time electronic music lover. Sorry for the half nudity. I am wearing shorts, don't worry. I'm calling out Fred. Fred's a bit of a music lover, and there's 2 photos here that are actually from the Netherlands. Music festivals, not necessarily what Fred likes, but this is electronic music. I'm a big fan of electronic music from the very early days. And this is just me with all my friends, and I've met worldwide friends from doing this as well. You're not going to get this next one, but I just want to put it in front of you as well. I'm also a part-time MC. What? Yeah, I was going to say that he didn't call me up. It's probably because I don't own kilt or bagpipes, but you know. So these events, like you're actually seeing on screen right now, only have happened in the last year, and the people, all the people down the bottom there in that final picture, they're all 50 plus, and all we're doing is just giving back to the community that just wants to hear this music because it's just some old school electronic music. All right, enough with the photos, yeah? Enough with the pinboard. I am also a part-time APROF, and I'm inside the University of Adelaide. Can be part-time everything, can't you? I'm a part-time APROF, and I've got a fantastic group amongst Australia and also inside my university that help out on the Aggie project and inside the Biometry Hub where I'm on the agricultural precinct of the Wake campus. The Wake campus is just really a melting pot of talent, to be honest. We have the Australian Wine Research Institute, CSIRO, the Biometry Hub, the Wake precinct, Adelaide University are all there, and the one big organisation, the Plant Accelerator, that takes on high throughput phenotyping, and they even have their own little data science team that we're connected to as well. So there's a fantastic amount of data that just even comes out of this as well. And we probably haven't worked so much with the Plant Accelerator in the past, but that's something that we're planning to change in the next couple of years. We'll be working a lot more closely with those guys and including their data scientists to try and push the high throughput phenotyping into the future. As on my little academic journey so far, I was a PhD inside AU under the tutelage of Ari Verbler, and I was doing much more theoretical statistics and biometrics, and I'm doing part-time consulting at the university as well, where it had an ag lean when it comes down to it. My PhD did actually contain data sets from agriculture, but it was very sparse, it was very theoretical, and it wasn't really until I started consulting inside the university that I started really getting into agriculture. And then I was at CSIRO for 6 years or 5 years. I was really getting into statistical genetics and building genetic maps and statistical modelling and doing variable selection in linear mixed models. And during those time in 2006, I found out I was a celiac, which is actually quite ironic because I was just working in the wheat and barley area. And I was also working in the genetic maps construction where we were injecting literally more glutenin alleles into the varieties that they were selecting. I was in a bit of a moral dilemma back then, but I overcome it after a little while. And then during 2011 to 2021, I've been in SAGI 2 and SAGI 3, which is the Statistics for the Australian Grains Industry. That's a Grants Research Development Council industry initiative. And that's the same people who fund Aggie. And the money has just been ramping up the whole time, and this turned into now a $36 million national GRDC funding initiative. $92 million total investment with in-kind and indirect in-kind. 3 major strategic partners, which you see in a minute, but we've also got multiple satellite partners, and we're even including the lovely people from Wageningen in those partners as well. That's coming up. We've just formed a collaboration with those guys, and we're going to be talking about alignment with them as well. So the idea behind Aggie is it's just got a broad analytical focus. We've gone from the old school SAGI days of just biometry and experimental design and statistical modelling and computational solutions. That's always been around to some degree. But GRDC had a different agenda. They wanted to inject machine learning, artificial intelligence, and all those lovely things I was just talking about before, data science, etc. And one of the big pushes was actually the machine learning and artificial intelligence agenda. They came and crowbarred our university and talked to the heads of school and the DVCR just to make sure that there was going to be some co-investment inside Aggie for us to move forward with our excellent Australian Institute of Machine Learning, one of the prestigious institutes in the world. They keep on telling me they're the 3rd best institute in the world, so I'm not too sure who the number 1 and 2 are. I think there's someone in Germany, but being 3rd, they're happy about that position. But the whole idea is that, again, we're bringing machine learning, bioinformatics, data science, mathematics, artificial intelligence. I put sampling in there as well. It hasn't been really looked at until now. But everything around that, analytics pipelines, you can pretty much bring all that melting pot together now into a bigger project with a bigger agenda and trying to push the Australian grains agriculture into the future. So much more on the domain side of things. Like this is probably a slide from GRDC more than anything else. You can see like the level of things we're trying to get involved with here. Everything from phonomics, like to even economics and supply chain. The classic statistics is still there with machine learning and artificial intelligence, data augmentation, really just trying to beef up everything. There's definitely the supporting of the plant breeding. That's kind of like why we're here as well. All the way through to genetics and bioinformatics as well, can't leave them out. So there is now just a very wide scope here and a very broad connection to the domain as well. And the whole concept is that the strategic partners are bringing some of that connection as well, including like the new people UQ. So just quickly, the Aggie AU, we were originally inside SAGI. We have some strengths in like biometry and statistical genomics and sampling and computing, but we're bringing in like new machine learning, the artificial intelligence. We've got data science and mathematics and optimization, data fusion and decision agriculture. That sounds like a bit of a weird term, but it's actually just about forming economic decisions around agricultural modelling, essentially, or crop modelling as well. And that's all of this melting pot now is inside Aggie, under my project lead. And it really is a very multidisciplinary, as Shanice said, a very multidisciplinary team. So Curtin University were also inside SAGI, and they're now in Aggie as well. They probably don't bring so much skill, but they do have some machine learning and computer vision and optimization and agribusiness, data fusion. But they were much more well known for like spatial modelling and on-farm analytics, and especially bioinformatics. In fact, like the Aggie team is inside the CCDM, which is the Crop Centre for Disease Management. So they have a big bioinformatics component that they've drawn over into Aggie. The new one on the block is Aggie UQ. Under Scott Chapman, he's bringing in like a very strong profile of machine learning and AI, computer vision, data analytics pipelines, big data computing, analytical plant breeding, and he has a strong domain focus as well. He knows how to link, he knows how to talk the link between like the analytics and the actual agricultural problems, especially through the plant breeding, high throughput phenotyping, remote sensing, all those sorts of lovely things. I'm calling GRDC like a kind of a collaborator on this slide, and I don't like to do that because I like to like kind of push them away most of the time because they're quite annoying. They manage like our project from a GRDC management level, but at the same time, they can be a little bit from an over-reporting perspective, they can be a little bit like a little annoying partner. But we work with these guys to make sure we can get things more efficient as much as they can be annoying. We have to keep on pushing forward, like to try and get things more efficient. We've got a director as well who helps overarchingly manage this project. So he is kind of wrangling us as the leads, and we have a whole governance structure that sits inside Aggie, a management committee and an executive committee that we have to go through to formalise projects that we actually propose inside Aggie itself. So Aggie's the melting pot of partners in front of you right now. You can see Wageningen is sitting up there. I've got a couple of people here from Australian National University that are here as well, and that's one of our major project partners. But we've also got QDPI, University of Western Australia, hyphen like international hyphen drone and data analytic pipelines, UAVs. There's NGIS, which is like a new data analytics pipeline of GIS inside Australia as well, and a couple of the DPIs that are sitting there too. We're starting to bring this very good collaboration, this very broad collaboration as well, and it's not necessarily just all about artificial intelligence and machine learning here. There's a whole big melting pot of biometrics and other technologies, especially like through people like Fred and Wageningen as well. So this is like my team, and I've just highlighted like the machine learning people in the middle here from the Australian Institute of Machine Learning. You can see there's two machine learning engineers. They're just two FTEs. They were brought onto the project as agile machine learning engineers, and the agility allows like essentially a pool of about 9 or 10 that can come in and out of projects when needed. Now, that's not necessarily the greatest thing in the world because research projects are not things you just come in and out of. But the idea is actually to get some of their time, and they can share that time amongst the machine learning engineers in other ways. But we've got other actual type programs inside Aggie where they're much more suited. The great thing about this is that there's actually quite a broad set of talent sitting just inside that highlighted set of machine learning people. There's like an education postdoc there who's very good at getting involved with like awareness campaigns and even going out to schools and building ML AI awareness amongst the community. Got a very unbelievable like professor, even though he's only 0.05 FT, he's very gracious in his time and actually bringing in other postdocs or other people that might be useful on the project. So even amongst this small group of people here, there's actually a bit of a wider group where they're connected to these people that are coming into the project as well as we need them. But you can see there's a broad selection here. Like there's also the biometrics people that are sitting in the Biometry Hub on the left-hand side here. There's domain people, Matt Knowling and Chris Preston and Vinay. They're all domain people in terms of much more closely linked to agriculture, sitting in that column. And then we have mathematical science people sitting under Professor Lewis Mitchell, who are now just starting to get involved like with modelling pests. And on the right-hand side there's a few partners, but there's probably actually more partners now because the slide's a little bit old. But we've got up to 10 HDRs, and these 10 HDRs are literally at every single one of the strategic partners. So UQ's got them, Curtin University's got 10 HDRs, and we're just slowly starting to fill them up. There's an intention, like basically as we build up these research collaborations with all the partners, that those HDRs will then end up filling up, maybe even across multi-institutions, with co-supervision across the institutions as well, working on some great problems. With the amount of things that are sitting here for all the people who've done project management before at such a large level, there's always a large amount of administration that goes along with this. And I've got a great team sitting at the top there that have been involved with like trying to get digital project management happening in a much more structured way so we can take care of what's going on and let the people work underneath this tree. So the Aggie program delivery happens across 3 separate major programs here. The service and support is us delivering analytical support to up to about 150 GRDC investments. So think about that, that's a large amount, about 50 each institution, each strategic partner. And we bring in other partners to help out with some of this as well. And that's from a pool of about 600 GRDC investments across the space. And there's a lot of a breadth in those GRDC investments, everything from plant breeding through to stresses, through to pathogens, to pests, to economics, to logistics. There is everything in there. GRDCs, the people who literally choose these 150 GRDC investments with a little bit of help from us, and they get priority help, and most likely because they align with our skill sets that are sitting inside the institutions. So the upskilling and awareness is about 10%. We've been, inside SAGI days, we were conducting courses. We had analytical internships and mentorships. And we're following suit from that, but I'll show you a little bit later what we're actually doing with that. We're kind of amping it up a little bit, like inside Aggie. And in the research and development space, sitting very similar to the amount of effort that we're putting into the service and support. We've got internal collaborative research analytics research activities of practical and emerging importance to the Australian grains industry. Oh, I was seeing that's right, okay, yep. And there's a leadership component here. Obviously, there's only way we're going to be able to manage this project is through leadership. But the major effort, the 95% of the effort there is sitting amongst those 3 programs. And we try to delineate those programs, but we know they're intertwined. They have to be intertwined. Some of the components of service and support are speaking to research and development and the other way around. In fact, the way we link these things is by actually thinking about what's that service and support. There's 600 investments there. Let's go into that and have a look about what are the future problems that are going to actually be occurring in the grains industry. And then we start building what we should be doing from a research perspective around that. So those ideas are informed by the whole service and support area. And then when we develop something, we can literally, or GRDC, and we disseminate it out to the Australian grains industry, GRDC can plonk it back into their tender documentation and say that we've completed this, you should be able to access this tool, and that trickle effect of the improvement actually occurs. And this occurs on both sides as well. We have training workshops and mentorships and internships informed by the practical needs of the researchers out there. And then all that new expertise, and this, you actually genuinely see this as well, all that new expertise, and there's probably like people have had this inside the room here as well, that new expertise, that quantitative expertise that people never had before, then goes back into that service and support area, and then we have a lift up about what people can do from a quantitative perspective when they won't be able to do it before. So part of our plan is that we have to align to GRDC's strategic plan as well. So all of these programs are aligned to their 2023-2028 plan. Much of like what we try and do when we're in research is trying to fit ourselves into Pillar 2, because Pillar 2 is the one where it's close to blue sky. So GRDC is willing to throw some risk at it. And when GRDC throws some risk at it, that means that we are probably going to enjoy ourselves like trying to actually have research projects that are sitting inside there. So Pillar 1 is more about like what's happening now and can we extract more information out of it. And so plant breeding sits like within Portfolio 3. And so we've got that right crop and right cultivar, breeding, MVT, GS, and phenology. But then like what can we get out further from this, like from some blue sky projects sitting in Pillar 2. That's GRDC's strategy, and we're aligning ourselves from research or from through these programs into those strategies. I said to myself that I was going to start this stopwatch, and I never did.
Oh, I got you.
I know you've got me, man. So the great thing about this is that we've got UQ coming on board, and they've brought in a lot of capability. So if anyone knows about the Inviter project, or even about the Invite project like that Fred and his team have been involved with, and they've been involved with this as well, Scott and his team are bringing in sensors and a whole bunch of other things, like in terms of field cameras and satellites and UAV into this particular project. And it's just MVT trials that are sitting next door to other MVT trials, but with all this extra technology involved. For them to be, or for people to be able to take photos, remote sensing, and a whole bunch of other streams of data. So from that, we can actually get trial level data augmentation, most likely like trial covariates, etc. But within that, we can get MVT plot level data as well, like where there's a potential, I'm highlighting there, some deep ML phenotyping that Scott and his team have been doing for quite some time, where we can use remote sensing photos, we can use UAV photos, and we can create mosaics and create like, we'll do computer vision on these mosaics and get access to traits like of the environment, of the plant, and anything else that might be worthwhile. So the last part of this project is obviously turning those computer vision proxy traits into something useful and providing that information back to people that can use them in a much better way, whether it be creating nitrogen use efficiency or like water use efficiency, etc. So this is a great capability that's been sitting around in pre-Aggie. And this is most likely, not most likely, is one of the reasons like why UQ were brought onto the Aggie project. So some other things that UQ are bringing in, they've been involved with the global wheat full semantic segmentation, huge collaboration amongst level global institutions, pixel level annotation of wheat spike, stem and leaf across all the diverse growth rate stages as well. This has been a big project. You can see it's only just been published, but it's been actually around for quite some time. I think there was even an online competition about parts of this as well. But if you think about that, there's so much information like that's happening there, all the way down through the whole of the plant level. You can create so many traits there that might be useful. And also driving that into the future with potentially other crops as well, from a technology perspective. And there's also, UQ's been involved with Crispin James in the 3D sorghum organ detection as well. There's even been motion capture, was it VoidNet, PointNet and SegVoidNet, but yeah, SFM, like structure from motion. Cameras have been taking photos or videos of the sorghum panicles, and then recreating simulated data that is potentially useful for doing simulation to real data. And it's quite incredible. I haven't got any of the videos here, but it's quite incredible some of the work that's been done there. And this is just in sorghum, so we could actually take this out into other crops in the future as well. So some great technology that's been brought in. From an AU perspective, we're probably much more light touch, like in terms of like from a computer vision perspective, but we've been involved like with genomic prediction, using an ML-based like variational Bayesian sparsity. This is something that happened in about 2020 to 2022 with a collaboration between AML and Professor Jarvan, who's in the Aggie project now, but also with James Walter when AGT were actually exploring the use of genomic prediction in this context. You can see that there's a big site there, like 10,375 lines, and a few other sites or a few other years, like with 2,800 lines. This is all not multi-environment, it was just all single site at the time. 18K genetic marker set, but a very good quality marker set, I should say as well. And the whole concept behind the variational Bayesian sparsity is that what's happening inside this neural network in the first layer is there's only weights that are equivalent to the number of like markers. And what they're doing is creating like a Bayesian sparse loss like function for those initial weights, but also simultaneously creating the rest of the network with an L1 loss, like basically for the rest of the weights, so you could do some sort of dropout, like to get some efficiencies there as well. But the whole concept is that what it creates is like a penalty or a penalised likelihood situation inside a Bayesian graphical network. And so you end up like with 300 to 400 markers that have a much more causal link to like grain yield in the end. And this actually proved to be very good. You're getting, it's probably hard to see maybe up on that screen, but you're getting actually better correlations, like better alignment and lower error from this feature selection sparse Bayesian ML. And it beats Bayes A and Bayes B. If anyone knows anything about Bayes B, that's also a feature selection type legacy, but it's linear based. And so there's a possibility here that like the non-linear based like neural network is actually reaching into something, some non-linear components here to reduce some of this error. So we generalised this to higher order interactions. This work is still ongoing, but the AML team come up with a fancy way of actually building the epistatic and beyond epistatic, like into like higher order interactions. Using this particular method. There's no details on this method right in front of you, it's a bit too tedious. But this actually proved to be useful as well. You can see like the error like with the top 500 interactions. And those interactions actually had everything from epistatic to third order to fourth order to fifth order. And it was allowed to go as far as like the depth of the network because they kept on building like the actual interactions through the depth of the network. And you can see like that there's a pinch point there like where you can actually choose like a set of interactions that prove to be better than like the legacy LMM approaches. We're just attempting to have a crack at like, this is things that have been left over from about 2023, have a crack at like the generalising to multiple environments with covariates. AGT left us some data that was had environmental covariates, had the full genetic marker set over about 70 environments. I think Daniels might have even worked with some similar set before him as well in one of his papers. And AML had this great idea of actually just linking like the covariates directly to the markers, like each set of covariates to the markers. And then they also built in the higher order interactions and they also built in the Bayesian graphical network. We're still playing with this like to try and see if we can get something a bit more. I'm not a full believer of this at the moment because I'm not necessarily a full believer of the genomic prediction from an ML perspective is the key, but I want to keep playing with it to see whether we can actually get somewhere. So the team like in AML as well, before Aggie came along, they also came up with, they also are involved like with fava bean emergence and beyond. You just saw my student Tim, who was talking about canola emergence. So this is in some sense very similar. We had high resolution like UAV images and AML took those. And I didn't realise how much they were going to run with the ball. Like even though they didn't have the information in front of them, they decided to run with the ball anyway. They ended up finding out doing the counts for the seedlings. Then they decided to like go one further and block out those seedlings and then start looking at the weeds around it. So they're doing weed detection. We didn't even ask them to do that. I think they were just trying to show their mettle, which was actually really good. And then they decided to like basically like do stubble detection by using some other methods as well, such as some zero or few shot algorithms. This was, to me, this was amazing. Like, and I wanted to see this sort of thing come into like Aggie. But the problem with that is that we needed data for that. And so AML was ready to get wild. They were literally ready to get wild. They'd done emergence, they'd done stubble detection, they'd done weeds, but they were ready to go for the full whole hog. Just trying to read the actual, like disease detection. Everything's in there, and they sensor integration, and also like deployment, et cetera, But they're missing some pieces of the puzzle here, aren't they, when you think about it? They don't actually have the data to be able to make these assertions or even like to get involved with this level of technology. That's the unfortunate component that's sitting inside AU at the moment. So this is a little, when we get to the point about like the MLA or ML-AI alignment inside Aggie. So I'm looking for these guys like basically across the spectrum of what they do. And they're actually very computational, they're very theoretical, there's an education piece in there. Everything from, especially the engineers, are all very good about like deploying machine learning and artificial intelligence. They're very good at like computer vision models, they're very good at theory, very good at education. Off-the-shelf ML, they can tweak those things as well. And they're also very good at generating large language models, like bespoke large language models, taking things from Hugging Face and tweaking them like into something that could be very useful. If you know what Hugging Face is, that's an open source like set of large language models that you can use to tweak your own versions. So there's me looking at this and going, I want to pipe them into something like extremely useful. Then AIM will come back at me with versions of what they want to do. And one of the first proposals that came in the early days, like inside Aggie, was crop chat, which I actually think is a genuinely great idea. But the problem is, and they even wrote it in the proposal as well, that it required a massive corpus of knowledge around being able to provide this chat interface, like in terms of like multimodal images, text, and anything else that would be useful to provide back to the farmers and growers so they could get information. Now, you're probably all sitting in the audience and going like, that sounds like a great idea, but there's also some problems with that we're going to touch on in a second as well. And then another one came in from my guru, Professor Zhao and Shi, about causal LLMs. And that also required a corpus of knowledge from the domain area. That was all about interventions such as irrigation, nitrogen, or anything else that might be considered to be an intervention. But again, what do you need? What do you need to be able to do that? You need data. If you're going to put something in your training set, like you need data. So why are they actually like saying all this stuff and they don't know the data? I think they're thinking the data exists, and they did think that some of this data actually exists. And I was just talking to other people like about this earlier this week. And when the data doesn't exist, I think they think you can impute it. That's just like machine learning people for you, like when they don't have enough domain knowledge. So part of the problem here is they're not socialized in agriculture like inside AML. They need to be socialized a lot more. So, and as we know, grains agriculture is dynamically complex, isn't it? And unfortunately, AU does not have access to large amounts of relevant data, so we've got to do something about that too. So, but in the complexity, like from a dynamic perspective, it's an open system inside agriculture, as we know. We've got genotype, by environment, by management, by trait, by time, by spatial. Want to keep going? Might as well keep going. By pest. We were coming up with some funny ones like that when I was out in looking at Edinburgh Castle, but you could keep going here. This is the way that I actually described back to them and said, I don't think you understand how complex this system is. Let me just describe it to you. And I just started putting them all in front of them, and they're like, oh, right, okay. And because I just don't think they actually get it, that it's a changing system, and especially in climate change, it's going to keep on changing, isn't it? So my idea was actually, let's align ourselves to UQ to start off with. That's got to be one of the key things that like I want to get AML involved with like projects that are associated with UQ. So continuing like the phenomics trait modelling, focus on expanding digital phenotyping efforts with the national and international collaborations. It's including like with Fred's group as well. The possibility of developing a foundational model that will actually possibly be able to be used across multiple species, with a huge amount of like worldwide wheat images, and then a simulation to real across different species as well. Like, thank you, Shanice. Is that 5 minutes or 3 minutes? I should just like skip through some of this so I can get to the good part, like where we're talking about some experimental design. So yeah, the use of the outputs described above and other peripheral data generate functional traits. So And there's also, we're thinking about the phenomics for plants and diseases as well. We're thinking about segmenting actual images of plant disease down into constituent parts. Now that's not as simple as it sounds, like, because you actually got to link this up with the pathology as well. So there's some proposals that are on the board. And again, we're going to bring all the partners on board to be able to do that, including like AML, because I know they're going to be great at some of this as well. So aligning to UQ was one of the things. We've got a couple of projects going on, including like a training program where we're building awareness into the actual industry sector. One of the things we're doing is we're doing stakeholder engagement to see what's missing pieces out there, to see what ML and AI missing pieces are there. We're bringing in Gina, and he's an unbelievable postdoc, passionate about education and awareness of ML and AI. And we intend to like start putting out workshops in phase 2 of this national industry training program to make sure that like farmers and growers know what's possible. When we know what's possible, then there'll be that lift up, and we'll be able to lift up our projects to like match them. We have been talking about causal learning. I'm just going to skip through this like kind of quickly as well. We've been talking about causal learning inside AU, and we've got a few projects that are up on the board. Like Jarvan is with his causal machine learning, wants to actually get involved with the project with all the way from genetic markers through to other data streams. And on the statistical learning side, we're getting very inferential, like with the statistics associated with these things as well. And we're trying to do this across like G by E by M landscapes as well. So some exciting work there, and I know Fred's group has actually got some connections to causal learning as well, so it'd be very interesting to talk to that group too. The last part of this talk, how's that sound? This is like 5 slides. I think we can do this. This is little bits and pieces of AI, ML in the context of like we have used large language models to generate some of the code here. But this is about an experimental design package speed. I just got sick of not being able to get access to OGW and maybe even just using legacy software Digger. But there was, every single time over the last 10 years, I've been designing like field trials and designing all trials to have spatial balance. Think about a Latinized design, like in the very simple sense here. I haven't got a picture for you, but where basically there's one version of the one replicate of the treatment or variety sitting in each row and column. That's the way to look at this. Now just burgeon that out like to something bigger, where you make sure that you minimise like the actual appearance of treatment replicates across the dimensions of the layout, no matter how large that actually is. So this is a good opportunity to vibe code. I wanted to let my boys go, like Sam and like Wasim, and see what they could do. We started like looking across the DeepMind and Claude and ChatGPT to do some of these things. And the great thing about that was, I'll just say, this is a fast, model-free solution. I want to put that out there. Yeah, no specific like package was attempting spatial optimality such as this. This is what it does every single time. But you can actually do custom objective functions. So just looking at the interface here, it kind of follows a little bit of like an ODW type interface, where you've got a swap where you're swapping treatments. You've got a swap within, let's just say that's a block where you're swapping the treatments within that when you're actually checking for new designs. And then the spatial factors are the things you want to balance, like your treatments or your varieties over. Now, those spatial factors don't need to be a row column layout. They could be anything, literally anything. This is not just designed for agriculture trials, but could be anything. And there's also an optimize. We're still thinking about this as an interface perspective. There's an optimize that actually can contain all the things you need, the swap within and spatial factors within list elements of optimize to do multi-optimization. I'm just going to go through that quickly. Yeah, so we vibe coded, if everyone's happy with that term. PIFO and Williams Euclidean distance and neighbour balance metrics, they're actually in the package as well, because we're kind of using them as a kind of a baseline to see how these things worked from a model-free perspective. And we did a new balance metric and a new adjacency metric, which was completely AI, like in terms of prompt engineered. And in some sense, it was so simple. I haven't got the notation sitting right here for you, but like it literally is just a variance of the treatment appearance in a particular layout. So thank you, 1 minute to go. And also the adjacency, which is just doing penalisation when treatment replicates or variety replicates are sitting near each other as well. Now, the great thing about this is it's model-free. It's super fast, like super fast, and it achieves spatial optimality just about in all cases in very difficult designs as well. So just quickly, in a 2D blocking scenario, which is like in some sense the semi-Latinized scenario that like Rosemary Bailey was talking about, This is a very difficult scenario. 20 rows and 20 columns, 40 treatments with 10 replications. Bit of an out there scenario, but we just wanted to test if we could actually push the limits here. So you're just swapping treatments within coal block, but then you've got a spatial factors roadblock that it uses to separate or to do the balance over, but it's got to keep things within coal block and also do that balance across roadblocks. So it achieves that and can do it almost consistently every single time, something that OGW actually struggles with because it's using A-optimality in a variance kind of minimization type way. So there's one particular hard design. There's another one here which is not fully implemented in the package at the moment, but it's just sitting there as about to be finished, pretty much. That's a full optimal MET design where you can actually spatially balance the allocation of varieties across the trials, and then you can actually allocate optimally within trials as the endpoint as well. And it'll just run through both optimizations before it spits out the results. So full MET trials with everything there. You can't really see it inside this picture, but it was just to show you we can do this with irregular trials as well. And you can even do it where you actually assign varieties to trials and then only swap the ones you want to swap between trials and then do the allocation within trials as well. So just quickly, we've got everything set up for randomized complete block designs, lattice, alpha, balanced incomplete block, partially replicated designs, 2D blocking I'm calling it, but it's the semi-Latinized as Rosemary said. It can do multi-factor one pass designs, strip plot, split plot, general multi-factor as in nested multi-factors as well, to whatever degree. The next things that are coming, one pass optimal allocation across multi-environment trials, as I said, multi-factor single optimization, have a think about basically balancing across multiple factors within your layout, where you're doing that for say treatment A and treatment B and the replicates across the actual trial separately, but in one pass. Treatment of variety relationship matrix incorporation, I automatically know how to do that in this model-free scenario. It's easy as hell. That's coming very shortly as well. And I even thought about environmental covariates, and I think that can be done too. I should probably finish there. I'm going to get in some serious trouble. Yeah. Take-home message for MLAI alignment. Find strong collaborators who have connected MLAI well to the biophysical domain. That is UQ, and we're teaming up with them with AMOR in our group. Find collaborators who are connected to a plethora of usable data. That's UQ again, and thank goodness they're on the project just for that fact alone. Socialise the biophysical domain as much as possible with MLAI scientists and align people to interesting, challenging problems and have some bloody fun.